We're beginning now in our dma020. dma020 is going to focus on fractions and decimals. And when I say fractions, I also mean mixed numbers, which is the combination of whole numbers with fractions. In dma10, we looked at integers, which was positive and negative whole numbers. So now that we're in dma20, we're going to deal with both positive and negative fractions, mixed numbers, and decimals. We're going to work with the computations of all of these, and we're going to learn how to do rounding of decimals. We're going to do a lot of word problems. We're going to convert between standard notation, scientific notation, and we're still going to do some geometric applications of formulas with the problem solving in both the format of fractions and decimals. So what we're going to start with will be some vocabulary that you will need to become familiar with. We're going to start with the term rational number. What is a rational number? A rational number is a real number that can be written as a simple fraction. So a representation of that could be something such as 3/4. It could be 2/7. It could be -8/10. Okay. When we talk about a fraction, there's three terms that we will hear referenced. We will be using the words such as proper fraction. A proper fraction is less than 1. You will be seeing the term improper fraction. This would be equal or greater than 1. And a mixed number is going to be a whole number and proper fraction. I'll give you an example of each of these. An example of each would be a proper fraction would be, let's say, 2/3. The numerator is going to be smaller than the denominator. 9/11. That would be a proper fraction. An improper fraction could be something such as 5/5. 5/5 is equal to 1 whole. If they are equal, or if the numerator is larger, that would be considered an improper fraction. A mixed number would be if I had, let's say, 9 and 2/3. I have a combination of a whole number along with a fraction, a proper fraction, that is. When you have a fraction, the fraction is going to be made up, and I'm going to write this abbreviation N over D, which means you have a numerator over the denominator. When you have a fraction, let me also give you another example here. Let's say we have this illustration, and let's say this is divided into 5 equal pieces. If I were to come here and I were to shade some of these pieces, if I asked you for a fraction for the shaded pieces, the numerator would be the number that is shaded. That would be the 2. The denominator is going to be the total number of parts that it's broken into. This rectangle is broken into 1, 2, 3, 4, 5 pieces. So the shaded part of this illustration would be 2/5. If I asked you to represent the unshaded portion, I would count the pieces that are not shaded. 1, 2, 3. 3 pieces are not shaded out of a total of, it is still a total of 5 pieces. So when you write a fraction, the numerator is the part that they're asking you for, and they'll specify what they're asking. The denominator would be how many even pieces that whole would be divided into. So as you start in your workbook and online, you will have some illustrations where you will be looking at drawings and identifying slices of pizza, how many pieces are shaded, things of that nature. When you are looking at graphing fractions, when you think about graphing fractions, think about a ruler, okay? So if I have a ruler and this end is the 0, and I'm just going to make my ruler go 2 inches. Okay, 1 inch here and second inch will be here. So when you look at a ruler, you know that it's divided into increments. So midway between each one, you would have another marking which would represent like the half. Inside of the markings, inside of each of those halves, you'll see another marking that would be representing, let me do it a different color. So the half is in the black. Here, we're going to make our quarters in the red. And then if we broke it down even smaller, let me use the blue, we can break it into eighths. So if I wanted to represent, let's say, 7/8, if I wanted to represent 7/8, to get to the one whole, I would have 1, 2, 3, 4, 5, 6, 7, 8 pieces. 8 out of 8, 8/8 would be the one whole. Also, 4/4 would be one whole. 1, 2, 3, 4. Also, a 2/2, this is the half, 1, 2, that would also be equivalent to one whole. But if I wanted to graph the 7/8, I would literally count 1, 2, 3, 4, 5, 6, 7. So right here would be where 7/8 would be. If I wanted to graph, let's say, a mixed number, let's say I wanted to graph the number 1 and 3/4. I would go over one whole, and then I would need to look at the tick marks for the fourth. That would be 1, 2, 3, 4. So these 1, 2, 3, 4, I would go 1, 2, 3. So right there would be represented by the 1 3/4. This can also be written, this is what we call a mixed number. This could also be written as an improper fraction. As an improper fraction, the denominator is still going to be 4. The way I can do this is I would do 4 times 1 is 4, 4 plus 3 is 7. So if I were to count, it would be 1, 2, 3, 4, 5, 6, 7. 7/4. So that's me writing this value as both an improper fraction and as a mixed number. In section 2, we are going to look at factoring, and we're going to look at factoring prime and composite numbers. Factors are numbers we multiply to get a product. Two times 5, those are factors of 10. So if I do 2 times 5, I get 10. Other factors of 10 would also be 1 times 10. So 1, 2, 5, and 10 would all be factors of the number 10. They divide evenly into something. We are going to look at two special kinds of numbers. Prime numbers only have 1 and itself as the factors. For example, the number 3 is a prime number. The only numbers we can multiply to get 3 are 1 times 3, and we're referencing whole numbers to get the product. Composite numbers have 3 or more factors. For example, okay, like for this one, we only have 1 times 3 as factors. If I gave you the number 9, for 9, we could multiply 1 times 9. We could also multiply 3 times 3. So we only have 1, 2, 3 factors, 1, 3, and 9. If I gave you the number 12, factors of 12 would be 1 times 12. We would have 2 times 6, and we would have 3 times 4. So if we listed the factors of 12, we'd have 1, 2, 3, 4, 6, and 12. We would have a total of 6 factors. So a composite number is going to have 3 or more factors. What we're going to start with is, oh, and let me put one little rule here though. 1, the number 1 is neither prime nor composite. We do not identify the 1 as either of those. It is just not prime, it's not composite. It's its own special entity. Okay, so what we're going to do is I want us to make a list of prime numbers, and we're going to make a list of composite numbers. When I make this list, if you're ever doing the prime factorization of something and you need to know what the prime numbers are, you can go through this exercise on your own and determine what's prime and composite. 1 is neither prime nor composite. So if I start with the number 2, the only factors of 2 are 1 times 2. So that means the number 2 is a prime number. 3. 3 is 1 times 3. It is a prime number. 4. 4, we have 1 times 4 and 2 times 2. So 4 is a composite number. For 5, we only have 1 times 5. It is prime. For 6, we have 1 times 6 and 2 times 3. 7, we only have 1 times 7. 8, we have 1 times 8 and 2 times 4. 9, we have 1 times 9 and 3 times 3. 10, we have 1 times 10 and 2 times 5. 11, we just have 1 times 11. 12, 1 times 12, 2 times 6, 3 times 4. 13 is prime. 14, we also have that 2 times 7. 15, we have a 3 times 5. 16, we've got the 2 times 8. And for all of these that I'm just naming another pair, it goes without saying 1 times that number. 16, 2 times 8, and 4 times 4. 17 is prime. 18, we've got 2 times 9 and 3 times 6. 19 is prime. 20, we got 2 times 10 and 4 times 5. 21, we got 3 times 7. 22, we got 2 times 11. 23 is prime. And I'm going to stop there, okay? When we look at prime factorization, which we're going to do in just a moment, with prime factorization, we're going to break our numbers down to these prime numbers, 2, 3, 5, 7, 11, 13, 17, 19, and there will be others that are prime. If you have any numbers that are composite, we're going to keep factoring them until we get them to their lowest factorable value, okay? So we're going to do that in just a moment. So what will help us as we're trying to factor numbers is there are some divisibility rules that we can look at. Divisibility rules. And if you will, I'm not going to list all the details of this. I'm going to make note to see page 2-7 in your workbook. So if you have your workbook, look at page 2-7. I'm not going to recopy all of this on the slide, but we're going to make note of each of these. If you were to have the number 2, if something is divisible by 2, it's divisible by 2 if it is an even number. An even number is going to end in either 0, 2, 4, 6, or 8. So if you have a number that ends in any of those digits, it's divisible by 2. Let me jump to the number 4. Something is divisible by 4 if the last 2 digits, are divisible by 4, then that number is divisible by 4. Like if I had, for example, 816, the last 2 digits are divisible by 4, so that number would be divisible by 4. For this one, if I gave you 36, the last digit is even, it would be divisible by 2. The rule for 6 is that if the rules for both 2 and apply, then you can know that that number is divisible by 6. The rule for 5 would be if the number ends in 5 or 0, then you can divide by 5. It's like counting by 5s, 5, 10, 15, 20, 25, 30, 35, 40. It's a multiple of 5 if it ends in 5 or 0. It's a multiple of 10 if it ends in 0. 20, 30, 40, 50, 60, 970, it ends in a 0, it's divisible by 10. Now, these last two, I wanted to do these two together for 3 and the 9. For 3, if the sum of the digits is 3, then the number is divisible by 3. If the sum of is divisible by 9, then the number is divisible by 9. Let me give you an example of this. Let's say I give you, and I'm going to do a simple one just so we can do this one in our head. Let's say I give you 18. And I want to know, let me do a different color. If I have 18, I would do 1 plus 8. That would be the sum of the digits. 1 plus 8 is equal to 9. Is 9 divisible by 3? Yes. So this number 18 is divisible by 3. Same rule applies here. 1 plus 8 is 9. 9 is divisible by 9. So the number is also divisible by 9. If I were to give you, let's say, 3, let me make up some numbers. 3, 5, 2. Okay, let's say I have this number, 3,522. That would be, let me not put an equals. That would be, adding the digits would be 3 plus 5 plus 2 plus 2. 3 and 5 is 8, 9, 10, 11, 12. The sum of the digits is 12. Is 12 divisible by 3? Yes. 3 times 4 is 12. So this number here is divisible by 3. Is 12 divisible by 9? No, not evenly. So that number is not going to be divisible by 9. This number you can't divide by 9, but you can divide by a 3. Now, if I come back to this rule for 6, 6 says if the rules for both 2 and 3 apply, this number is even, so it's divisible by 2, and I added the sum, and this number is divisible by 3, so both of those rules apply. This number can be also divisible by the number 6. So these are just some rules to help you as you're trying to do some divisibility of numbers. Now, you're going to learn how to use your calculator to do all of these, but these are some rules that you can kind of use as you work in your head and are trying to do those calculations mentally with mental math. Let's do the prime factorization of a number, okay? When we do the prime factorization, we're going to factor the number completely to prime numbers. That would be the 2, 3, 5, 7, 11. We're going to factor to prime numbers. There are different ways that you can factor and do the prime factorization. I'm going to show you the method that traditionally is taught first, which is using the factor tree. Let me make note here. People reference this as the factor tree, and this is probably what you will have seen when you may have prior experienced prime factorization. I'm going to give you this example, and I'm going to write it out 4 ways. If I want to do the prime factorization of the number 100. And by me showing you this kind of lets you know why I like to do mine in a different method. And I'll show you the method that I prefer to teach. If I do 100 and I say, I want you to factor this, everybody's going to give me different possible combinations. One person might say, okay, I can factor that into 10 times 10, okay? Another person's going to say, well, I think it would be 2 times 50. Another person is going to give me 4 times 25. And another person is going to give me 5 times 20 as all the possible ways to factor. When I've taught this in times past, just this first step here makes some people get confused and they don't know from here, which one do I use? Which is the correct one? It really doesn't matter. You can use any of them, okay? I'm going to do it with all of these just so that you can see how to go about factoring. The 10 can still be factored into a 2 times 5. This 10 can still be factored also into a 2 times 5. Now, 2s and 5s, I can't factor any further. With this next one, if I continue factoring, the 2 is a prime number. I can factor 50 into 10, but then I can still factor this 10 into a 2 times 5. So, do you see this factoring had to go out a little bit further? For this factoring, the 4 would be 2 times 2. The 25 would be 5 times 5. For this last example, I bring the 5 down. The 20 is going to be a 4 times 5. I can still factor that 4 into a 2 times 2. And with any of these methods, you'll see the final answer we have is they all have 2 2s and they all have 2 5s. This could be written out long way as this, or you could write 2 squared times 5 squared. Either of those would be acceptable answers. Now, to me, this seems a little more confusing because you have a lot of possibilities of where to start to get to the final answer. Some were in one step, and then others it took several more steps. Let me show you the way I like to do my prime factorization. What I like to do is Over to the side, I'm going to make a list of my prime numbers. Prime numbers are 2, 3, 5, 7, 11, 13, etc. Okay? If my number is 100, I'm going to start with the number 100, and I just call this the ladder method. It's not really a ladder, but to me that's what it looks most like. So what I would do is I write down the number I'm factoring. I draw like an L, like a ladder run around the 100. What I'm going to have in front here is going to be, this will be prime numbers. I only put numbers here if they're prime. I'll start with the very first digit. The first digit here is a 2. I'll use those divisibility rules. Does 2 go into 100? It's even, so yes. 2 will go into 100 how many times? It'll go into 100 50 times. I'm going to stick with that number 2 till 2 doesn't divide anymore. 50 is also even. 2 will go into 50 how many times? 25 times. 2 goes into 50, 25. Does 2 go into 25? No. 2 does not factor into it anymore. I can mark it out. I'm going to go to the next number, 3. Does 3 go into 25? 5 and 2 is 7. 7 is not divisible by 3. So no, 3 does not go into it. Does 5 go into 25? It ends in 5 or 0. So yes, 5 will go into it. 5 goes into 25 5 times. I'm still sticking with the number 5. I'm not done with it. Does 5 go into 5? Yes, 5 goes into 5 one time. And when we get here, when you get to the 1, you stop. Your answer are going to be these numbers in this column. And notice they're already in order. 2 times 2 times 5 times 5. That's your 2 squared times 5 squared. You can write it either of those two ways when you do your final solution. These are not decimals. These are the little dots for multiplication. So I like to use this method. Now, the other thing when I do this is I would use my calculator. Start with the 100, divide by 2, that gives you the 50. Take the 50 and divide by 2, that gives you 25. When I take the 25 and I go to divide by 2, it's not an even number, so I can't use the 2. Take the 25, divide by the 3. Again, it's a decimal, it's not a whole number. Take the 25, divide by the next prime number, it's a 5. And then 5 divided by 5 gives us 1. And when you get to 1, then you know you're done. So you may use your calculator when you are doing prime factorization. Let's do one more of these, okay? So with this next one, I'm going to list some prime numbers off to the side. 2. I like to write them down so I have something I can mark on and eliminate things as I go. The number we're going to factor, we're going to do the prime factorization of 297. And let me go ahead, I'm going to draw a couple of these since I'll have to keep changing my pen back and forth. Okay, so I'm going to start with 2. Will 2 go into 297? Let's use the calculator and just check everything. 297 divided by 2. No, it's not even, so I cannot use the 2. Let's try the number 3. 297 divided by 3, it's 99. So yes, I can use the 3. 3 goes into 297 99 times. Does 3 go into 99? 99 divided by 3, yes, evenly 33 times. 3 goes into 99 33 times. We're still on 3. Does 3 go into 33? 33 divided by 3 is 11. 3 goes into 33 11 times. Does 3 go into 11? Okay, take your 11 divided by 3. No. Okay, so I can mark out the 3. Does 5 go into 11? 11 divided by 5? Nope, not evenly. Let me mark that out. Next number is 7. 11 divided by 7, no, does not go. So we mark out the 7. 11. 11 into 11 goes one time. So here, 11 goes into 11 one time. We're at the 1, so that lets us know that's where we stop. So our prime factorization is 3 times 3 times 3 times 11. Or you could write 3, there's 3 of them, 3 to the third power times 11. You could write either of those for your method for that. So this is the way I like to do prime factorization, because you have a plan and you go through each of those numbers until it divides out and you come to the number 1. Okay. The next thing we're going to look at is simplifying a fraction. What are equivalent fractions? Okay. So equivalent fractions represent the same amount. Equivalent fractions represent the same amount. So for example, let's say if we had a pizza, and let's say this pizza was cut into 2 pieces, and you ate one of the 2 pieces. You would have eaten 1/2 of the pizza. We're going to pretend my drawings are the same. They're equal size. If this pizza is divided into 4 pieces and I ate 2 of the 4 pieces, I'm still eating 1/2. If my pizza is divided into 6 even pieces, 3 of those 6 pieces, that is still half. If I have a pizza that's divided into 8 even pieces and I eat 4 out of the 8, it is still an equivalent amount. So equivalent fractions represent the same amount, but we're using different numbers to do so. If we are asked to write in simplest forms, if we want to simplify a fraction. If you remember from dma10, we can multiply any number times 1 and still have the same amount. The same thing applies whether you're multiplying or whether you're dividing, you're still going to get 1. If you multiply or divide by 1, you still have an equal amount. If I were to give you, let's say, 12 over 15, if I wanted to simplify this, both of these numbers are divisible by 3. I can divide 12 by 3 and I can divide 15 by 3. 12 divided by 3 is 4, and 15 divided by 3 would be 5. This fraction I can divide by 1 whole, and it gives me an equivalent fraction. So 12/15 reduces to 4/5. The way the workbook will show you to do this is to factor to prime numbers. The 12 would be 2 times 2 is 4, 4 times 3 is 12. The denominator would be 3 times 5 is 15. I would then cancel out what they have in common. They both have in common a 3 over 3. 3/3 is that 1 that canceled. What I'm left with is 2 times 2, which gives me 4 over 5. Now let me show you one other thing that you're going to find very interesting here. I like to show you your calculator steps. Calculator steps. If I'm going to do this problem on the calculator, I'm going to type in 12 divided by 15. I'm going to press enter. That's like your equals. Then I'm going to press the key that says math. And then I'm going to press enter 2 more times. So let's do that together. I'm going to type in 12 divided by 15. When I press enter, it gives me a decimal. When I press math and enter 2 times, 2 times, it gives me a simplified fraction of 4/5. So anytime that you are needing to simplify, if you're needing to simplify 64 over 20, you would press math, enter, enter, and it would give you that improper fraction 16/5. Okay? Are they equal? One way that you can determine if fractions are equal to each other, if they're equivalent, that's the word that we'll be using because the numbers are not identical. If I want to know if things are equivalent, let me start with something like this. Let me do 2/4 and 3/6. If I want to determine if they're equivalent, we're going to cross multiply. If I multiply 4 times 3, I get 12. When I multiply 6 times 2, I get 12. These two numbers are the same, so yes, those two are equivalent. If I give you 3/5 and let's say I give you 4/7, I want to determine are these equivalent. 5 times 4 is 20. 7 times 3 is 21. Are those two numbers the same? No, those are not equivalent fractions. So that's an easy method to use when you're trying to determine if what you have is equivalent, okay? Let's now look at section 3. Section 3 is multiplying and dividing. So as we're looking at multiplying fractions, when we multiply these, let me give you a sample problem. I'm going to give you 3/2 times 8 over 27. The way they show you is they do everything to prime numbers first and then cancel out what is in common. The way I like to do this, if you remember those divisibility rules that we looked at earlier, if you have a numerator and a denominator with that meets a divisibility rule, you can simplify things. So I like to look at my original problem, and when I see the 2 and the 8, you're looking at a numerator and denominator. They can be above each other or diagonal. The 8 and the 2 are both even. I can divide 2 by 2 and I get 1. 2 goes into 8 4 times. So I'm going to mark on this problem and go ahead and reduce that. When I look at the 3 and the 27, 7 plus 2 is 9. 9 is divisible by 3. So 3 goes into 3 once. 3 goes into 27 9 times. So when I do these, I like to look at the original, see what's in common, and reduce that. Now, 1 times 4 is 4. 1 times 9 is 9. And then there is no more reducing. 4 ninths is in lowest terms. So if I'm doing it longhand, that's the approach that I like to take. Let's do another one longhand. Let's throw in a negative. Let's do negative 5/6 times a negative 8/15. A negative times a negative is going to give us an answer that is, guess what? Positive. So our answer here is going to be positive. Now let's look at the numerals. The 5 and the 15 are both divisible by 5. 5 goes into 5 once, it goes into 15 3 times. 8 and 6, they're both even. 2 goes into 6 3 times, 2 goes into 8 4 times. 1 times 4 is 4, and 3 times 3 is 9. I didn't mean to get the same answer, but it just worked out that way. So that is a 4 nights. If I were to be doing this problem and I'm using my calculator, let me show you how to type these in on the calculator. Let's see, we have 3 halves and 8/27ths, and we had a negative 5/6 and a negative 8/15. There's different ways you can type in fractions on the calculator. So let me show you. On the calculator, you may, if you had just like I did a minute ago, if I simplified a fraction, if I were to simplify, I typed in 8 divided by 24. That's okay if I'm just reducing and then do math, enter, enter. But if I'm going to multiply it by something, I need to type in 8/20ths in a parenthesis. I can do parenthesis. Actually, let me do the problem we have here. Our problem was, let's start with the 3 halves. I would do parenthesis, 3 halves, and then I would do another parenthesis because I'm going to multiply it by 8/27. Close your parenthesis. So you may type it literally with those in parentheses. So you would do parenthesis 3 divided by 2, parenthesis, left parenthesis 8 divided by 27, close parenthesis, and then you press enter. So once we type it in, we press enter, and then we do math, enter twice. Math, enter, enter. And then after that, you do math and enter 2 more times. That's one way to type that in, okay? Same thing with this one. We'll do a parenthesis. We're doing the negative. 5 divided by 6, parenthesis, the negative, 8 divided by 15. And then we follow these, enter, and then math, enter, enter. So here it would be parenthesis. When I wrote the word negative, I meant so you use this and not the minus sign. So we're going to do negative 5 divided by 6, and then negative 8 divided by 15. And then math, enter, enter. Okay, that's one way that you can do it. Let me show you another way that you can type in a fraction. Another way that you can type in fractions on the calculator would be, okay, press alpha. Does everybody see their alpha key? You're going to press alpha and then y equals, and you hopefully will see this box come up, okay? So let me write that down. Alpha, and then you press y equals. Alpha y equals. And then you're going to choose either of these. Number 1 is for a regular fraction. 1 is a fraction. 2 is going to be for a mixed number. 2, you have a whole number, and then, so this is for fraction. 2 will be chosen when you want to do a mixed number. Number 3 is when you're changing to convert a fraction to a mixed number. To convert fraction to mixed number. And then the last one is to convert a fraction to decimal. Fraction to decimal. Okay, so let's do that first problem. I'm going to choose number 1. And when I choose it, do you see how it looks like a fraction? And some of you might like to do it this way. Then you type in 3, you got to arrow down and do the 2. use the right arrow to move it over, times, and then we're going to do alpha y equals number 1, and then I can type in my 8 over 27. And then when I press enter, when I do it this way, I'm typing it as a fraction. It gives it to me as a fraction, so I am not having to do the math enter to convert the decimal to a fraction. So there's 2 ways you can go about doing it. It doesn't matter which you use, whichever you prefer. I usually do the other because I'm faster typing down here than having to use the arrow keys. But I find a lot of people like to do this, and they prefer to do theirs where they are typing it in where you have, wait a minute, let me clear that again. So we have 5 over 6. Let me move in front. I forgot to put my negative. And before I do the right parenthesis, I got to be completely out from under everything. So you kind of get into a few little clicks there. Let me do that negative first, then do my alpha y equals number 1. And then I'll type in my 8 over 15. So even on the second one, I could type it in this way. So you have an option of which way you prefer to type it, and that's absolutely okay for you to do it either way, okay? The next concept that we're going to mention, and we're going to mention this just before we start dividing. When we divide, we actually never divide. We're going to multiply by the reciprocal. Well, you may ask yourself, what is a reciprocal? A reciprocal is, the simplest way, is that it is a flipped fraction. That means we flip it upside down. Another thing that we can say for a reciprocal, the 2 numbers, it would be 2 numbers whose product is 1. It's also called the multiplicative inverse. So if I gave you, let's say, 5/7, that's the given number. The reciprocal would be 7 over 5. I would flip the numerator and denominator upside down. If you were given a whole number, let's say you were given the number 3. If you're writing the reciprocal, the whole number 3 technically is over 1. So the reciprocal of a whole number would be the 1 over 3. When we look at dividing fractions, the simplest way to write out the rule for dividing fractions would be that we are going to keep the first one the same. We are going to change division to multiplication. We are going to flip the second fraction. We will then multiply, and we will then simplify. So keep, change, and flip. That's what we're going to do. So let me give us an example of a division. So for the division, let's say we have 3 halves divided by 11 over 5. The first one we're going to keep the same. We are going to change the division to multiplication, and we are going to write the reciprocal. So when I flip this, it would become 5 over 11. Now I multiply. 3 times 5 is 15. and 2 times 11 is 22. So we keep, we change, and we flip. So when we are doing a division problem, that's what we're going to do if we're working the problem longhand. Now, if you're going to use your calculator to do this, let me make notes down here. If you're going to use calculator, I want you to type in the original problem. Do not type in where you did the change and flip, because what if you made a mistake or did something incorrectly? If you always go back to the original. So if I'm going to do this, this would be, I'll type it in both ways, 3/2 divided by 11/5. That's how I would type it in if I use the parentheses. Math, enter, enter. 15/22. Or if I used alpha y equals, I would type in my 3/2 divided by alpha y equals number 1 and type in my 11/5. So you would still type it in the original way with the division sign, and as you see, it gives us that correct answer.